For the Master Electrician Exam in 2023, you will be using the 2022 edition of the National Electrical Code, or NEC. When you study for the business questions, there are several resources to consider. Firstly, look for an exam study guide. The NFPA 70 Master Electrician Exam Study Guide, denoted as NFPA 70 MESC, is a good starting point. Secondly, consider study materials for business management topics. Electrical Business Management, a practical guide published by Brady, and the Electrical Construction Business Handbook authored by MacLeod and Nolan are helpful resources. Thirdly, you can consider study materials on code interpretation and application. The Electrical Code Interpretation and Application, authored by Wildy, as well as the Code Check Electrical Residential, Commercial, Industrial, published by Thomson, are good resources. Fourthly, for general business practices, consider Business Finance for the Electrical Contractor written by Harris and Estimating and Bidding for Electrical Contractors written by Bidwell. Fifthly, when studying business law, look at Construction Law for the Contractor written by Arnold and the Electrical Law and Business Guide for the Contractor written by Goldstein. Here are some additional tips for studying. 1. Join a Master Electrician Exam preparation course or study group. 2. Practice answering exam-style questions using online resources or study books. 3. Review the NEC thoroughly, paying close attention to sections relevant to business operations, such as Article 90.1 General and Article 110.1 Requirements for electrical installations. 4. Familiarize yourself with the latest industry standards and best practices. 5. Seek guidance from an experienced master electrician for mentorship or additional insights. Article 90.1 covers the purpose and scope of the NEC. It emphasizes the practical safeguarding of persons and property from hazards arising from the use of electricity. It is important to understand that the NEC is not a design specification nor an instruction manual for untrained persons. The code provides minimum requirements and is intended to be applied in a practical working manner. Understanding the relationship between the NEC and other standards, such as those from ANSI, ALL, and NEMA, is crucial. The NEC often references these standards for specific product listings and testing requirements. You should familiarize yourself with these organizations and their roles in electrical safety. Article 110.1 outlines the general requirements for electrical installations. It covers topics such as approved equipment, mechanical execution of work, and sufficient access and working space around electrical equipment. It's also crucial to understand the requirements for electrical connections, including proper torquing of connections and the use of approved connectors. Additionally, you should be familiar with the NEC requirements for arc flash hazard analysis and labeling. This includes understanding the different hazard risk categories and the appropriate personal protective equipment or PPE required for each. Grounding and bonding requirements are also covered under Article 110.1. This is the practice of intentionally creating a low impedance path to earth to facilitate the operation of overcurrent devices and limit voltage rise during electrical faults. You should know the difference between equipment grounding and system grounding, and the specific requirements for each. The NEC contains numerous tables, such as those found in Chapter 9 and Annex C, that are essential for determining conductor ampacity, conduit fill, and box fill calculations. Knowing how to properly use these tables is crucial for accurate and safe electrical installations. Also, it's important to understand how to apply the NEC directing factors for ambient temperature and the number of conductors in a raceway. These factors can significantly impact conductor ampacity and must be considered when designing and installing electrical systems. The NEC has specific requirements for overcurrent protection, including the selection and installation of circuit breakers and fuses. You should be familiar with the different types of overcurrent devices and their characteristics, such as time delay, instantaneous trip, and dual element fuses. You should also understand the NEC rules for coordination of overcurrent devices to ensure selective tripping during faults. Article 250.1 of the NEC provides the requirements for grounding and bonding, which are crucial for electrical safety. Effective grounding and bonding ensure that fault currents can safely return to the source tripping over current protection devices and minimizing the risk of electric shock. Grounding electrodes, such as ground rods, ground plates, and metal water pipes, are used to establish a connection to the earth. The NEC specifies the minimum size and installation requirements for these electrodes to ensure they provide a low impedance path to ground. Bonding is the process of connecting non-current carrying metal parts together to create an electrically conductive path. This includes bonding metal enclosures, raceways, and equipment to the grounding system. The NEC specifies the size and type of bonding conductors required for different applications. The main bonding jumper is a conductor that connects the equipment grounding conductor to the grounded conductor at the service equipment. This jumper provides a path for fault current to return to the source, tripping the overcurrent protection device. The equipment grounding conductor, also known as the EGC, is used to connect non-current carrying metal parts of equipment to the grounding system. The EGC provides a low impedance path for fault current to return to the source, protecting against electric shock. Understanding the requirements for sizing and installing grounding and bonding conductors is essential for ensuring electrical safety. The NEC provides tables and guidelines for determining the appropriate conductor size based on the size of the overcurrent protection device. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults and interrupt the circuit, protecting against electric shock. The NEC requires GFCIs in specific locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. Arc fault circuit interrupters, or RFCIs, are devices that detect arc faults and interrupt the circuit, protecting against electrical fires. The NEC requires RFCIs in specific locations, such as bedrooms and living areas, where there is a higher risk of arc faults. Surge protective devices, or SPDs, are devices that protect against voltage surges, such as those caused by lightning or power surges. The NEC recommends the use of SPD to protect sensitive electronic equipment from damage. Understanding the different types of SPD and their installation requirements is essential for protecting electrical systems and equipment. Article 300.1 of the NEC provides the general requirements for wiring methods. These requirements cover topics such as the installation of cables, raceways, and enclosures, as well as the protection of conductors from physical damage. The NEC specifies the types of wiring methods that are permitted for different applications. This includes rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic conduit. The NEC also specifies the types of cables that are permitted for different applications. This includes non-metallic sheathed cable, armored cable, metal-clad cable, and underground feeder and branch circuit cable. Raceways are enclosed channels that are used to protect and support conductors. The NEC specifies the types of raceways that are permitted for different applications, as well as the requirements for their installation. Enclosures are used to protect electrical equipment from the environment and to provide a safe working space for electrical workers. The NEC specifies the types of enclosures that are permitted for different applications, as well as the requirements for their installation. Conductors must be protected from physical damage by using appropriate wiring methods and enclosures. The NEC specifies the types of protection that are required for different applications. The NEC contains specific requirements for the support and securing of cables and raceways. These requirements are designed to prevent damage to the wiring system and to ensure that it is properly installed. The NEC requires that all electrical equipment be installed in a neat and workmanlike manner. This means that the installation must be free from defects and must be installed in accordance with the manufacturer's instructions. Article 400.1 of the NEC covers the requirements for flexible cords and cables. Flexible cords and cables are used for connecting portable appliances and equipment to a power source. The NEC specifies the types of flexible cords and cables that are permitted for different applications. This includes cords for lamps, appliances, and power tools. The NEC also specifies the ampacity of flexible cords and cables, which is the maximum amount of current that they can safely carry. The ampacity of a flexible cord or cable depends on its size, type, and insulation. Flexible cords and cables must be protected from physical damage by using appropriate strain relief devices and connectors. The NEC specifies the types of strain relief devices and connectors that are required for different applications. Flexible cords and cables must be properly connected to the power source and to the appliance or equipment. The NEC specifies the types of connections that are permitted for different applications. Flexible cords and cables must not be used as a substitute for fixed wiring. Fixed wiring is the permanent wiring that is installed in a building. Flexible cords and cables must not be run through walls, ceilings, or floors. They must also not be concealed behind building materials. Flexible cords and cables must be used in accordance with the manufacturer's instructions. The manufacturer's instructions provide important information about the proper use and installation of flexible cords and cables. Article 430.1 of the NEC covers the requirements for motors, motor circuits, and motor controllers. Motors are used to power a wide variety of equipment, including pumps, fans, compressors, and machine tools. The NEC specifies the requirements for the installation of motors to ensure that they are safely and reliably operated. Motor circuits are the wiring systems that supply power to motors. The NEC specifies the requirements for the design and installation of motor circuits to ensure that they are properly protected from overcurrent and short circuits. Motor controllers are devices that are used to start, stop, and control the speed of motors. The NEC specifies the requirements for the installation of motor controllers to ensure that they are properly protected from overloads and short circuits. The NEC requires that motors be protected from overcurrent by using fuses or circuit breakers. The size of the overcurrent protection device must be based on the motor's full load current. The NEC also requires that motors be protected from overload by using overload relays. Overload relays are designed to trip the motor circuit if the motor is subjected to an overload condition. The NEC specifies the requirements for the grounding of motors and motor circuits. Grounding is required to protect against electric shock and to ensure that the motor circuit operates properly. The NEC also specifies the requirements for the disconnecting means for motors. The disconnecting means is a device that is used to disconnect the motor from the power supply. The NEC requires that the disconnecting means be readily accessible and capable of being locked in the open position. Article 440.1 of the NEC covers the requirements for air conditioning and refrigeration equipment. Air conditioning and refrigeration equipment is used to cool and heat buildings and to preserve food and other products. The NEC specifies the requirements for the installation of air conditioning and refrigeration equipment to ensure that it is safely and reliably operated. The NEC requires that air conditioning and refrigeration equipment be protected from overcurrent by using fuses or circuit breakers. The size of the overcurrent protection device must be based on the equipment's nameplate rating. The NEC also requires that air conditioning and refrigeration equipment be protected from overload by using overload relays. Overload relays are designed to trip the equipment circuit if the equipment is subjected to an overload condition. The NEC specifies the requirements for the grounding of air conditioning and refrigeration equipment. Grounding is required to protect against electric shock and to ensure that the equipment operates properly. The NEC also specifies the requirements for the disconnecting means for air conditioning and refrigeration equipment. The disconnecting means is a device that is used to disconnect the equipment from the power supply. The NEC requires that the disconnecting means be readily accessible and capable of being locked in the open position. Article 500.1 of the NEC covers the requirements for hazardous locations. Hazardous locations are areas where flammable gases, vapors, liquids, or dusts are present or may be present in the air in sufficient quantities to cause an explosion or fire. The NEC specifies the requirements for the installation of electrical equipment in hazardous locations to ensure that it does not create a source of ignition. Hazardous locations are classified into different classes, divisions, and groups based on the type of hazard that is present. The NEC specifies the types of electrical equipment that are permitted in each class, division, and group. The NEC requires that electrical equipment that is installed in hazardous locations be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain an explosion within the enclosure and to prevent it from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to limit the amount of energy that is released into the hazardous location to a level that is below the ignition energy of the flammable substance. The NEC also specifies the requirements for the wiring methods that are used in hazardous locations. The wiring methods must be designed to prevent the ingress of flammable substances into the electrical equipment. The NEC requires that all electrical equipment that is installed in hazardous locations be properly marked to indicate its suitability for use in the specific hazardous location. Article 517.1 of the NEC covers the requirements for healthcare facilities. Healthcare facilities are buildings or portions of buildings that are used for the diagnosis, treatment, or care of patients. The NEC specifies the requirements for the installation of electrical equipment in healthcare facilities to ensure that it is safe and reliable. The NEC requires that healthcare facilities have an essential electrical system that is designed to provide power to critical areas in the event of a power outage. The essential electrical system must be capable of providing power to life safety equipment, critical care areas, and other essential loads. The NEC also requires that healthcare facilities have a grounding system that is designed to protect patients and staff from electric shock. The grounding system must be designed to minimize the voltage between different points in the patient care area. The NEC specifies the requirements for the installation of electrical equipment in patient care areas. Patient care areas are areas where patients are likely to come into contact with electrical equipment. The NEC requires that electrical equipment that is installed in patient care areas be designed to minimize the risk of electric shock. Article 547.1 of the NEC covers the requirements for agricultural buildings. Agricultural buildings are buildings that are used for the production of crops or livestock. The NEC specifies the requirements for the installation of electrical equipment in agricultural buildings to ensure that it is safe and reliable. The NEC requires that agricultural buildings have a grounding system that is designed to protect livestock and workers from electric shock. The grounding system must be designed to minimize the voltage between different points in the livestock area. The NEC specifies the requirements for the installation of electrical equipment in livestock areas. Livestock areas are areas where livestock are likely to come into contact with electrical equipment. The NEC requires that electrical equipment that is installed in livestock areas be designed to minimize the risk of electric shock. Article 600.1 of the NEC covers the requirements for electric signs and outline lighting. The electric signs and outline lighting are used to attract attention to businesses and to provide illumination. The NEC specifies the requirements for the installation of electric signs and outline lighting to ensure that they are safe and reliable. The NEC requires that electric signs and outline lighting be protected from overcurrent by using fuses or circuit breakers. The size of the overcurrent protection device must be based on the signs or lighting's nameplate rating. The NEC also requires that electric signs and outline lighting be grounded. Grounding is required to protect against electric shock and to ensure that the sign or lighting operates properly. The NEC specifies the requirements for the disconnecting means for electric signs and outline lighting. The disconnecting means is a device that is used to disconnect the sign or lighting from the power supply. The NEC requires that the disconnecting means be readily accessible and capable of being locked in the open position. Article 625.1 of the NEC covers the requirements for electric vehicle charging systems. Electric vehicle charging systems are used to charge electric vehicles. The NEC specifies the requirements for the installation of electric vehicle charging systems to ensure that they are safe and reliable. The NEC requires that electric vehicle charging systems be protected from overcurrent by using fuses or circuit breakers. The size of the overcurrent protection device must be based on the charging system's nameplate rating. The NEC also requires that electric vehicle charging systems be grounded. Grounding is required to protect against electric shock and to ensure that the charging system operates properly. The NEC specifies the requirements for the disconnecting means for electric vehicle charging systems. The disconnecting means is a device that is used to disconnect the charging system from the power supply. The NEC requires that the disconnecting means be readily accessible and capable of being locked in the open position. The NEC also includes requirements for the location of electric vehicle charging systems. The charging system must be located in a safe and accessible location. The NEC also includes requirements for the wiring methods that are used to connect electric vehicle charging systems. The wiring methods must be designed to prevent the ingress of water and other contaminants. Article 680.1 of the NEC covers the requirements for swimming pools, fountains, and similar installations. Swimming pools, fountains, and similar installations are areas where water is present and where people may come into contact with electrical equipment. The NEC specifies the requirements for the installation of electrical equipment in these areas to ensure that it is safe and reliable. The NEC requires that swimming pools, fountains, and similar installations be protected by ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electric shock. The NEC also requires that swimming pools, fountains, and similar installations be bonded. Bonding is the process of connecting all metal parts of the electrical system together to create an electrically conductive path. Bonding is required to minimize the risk of electric shock. The NEC specifies the requirements for the installation of underwater lighting in swimming pools and fountains. Underwater lighting must be installed in accordance with the manufacturer's instructions. The NEC also specifies the requirements for the location of electrical equipment around swimming pools and fountains. Electrical equipment must be located at least 5 feet away from the edge of the water. Article 690.1 of the NEC covers the requirements for solar photovoltaic, or PV, systems. Solar PV systems are used to generate electricity from sunlight. The NEC specifies the requirements for the installation of solar PV systems to ensure that they are safe and reliable. The NEC requires that solar PV systems be protected from overcurrent by using fuses or circuit breakers. The size of the overcurrent protection device must be based on the system's output current. The NEC also requires that solar PV systems be grounded. Grounding is required to protect against electric shock and to ensure that the system operates properly. The NEC specifies the requirements for the disconnecting means for solar PV systems. The disconnecting means is a device that is used to disconnect the system from the power supply. The NEC requires that the disconnecting means be readily accessible and capable of being locked in the open position. The NEC also includes requirements for the location of solar PV systems. The system must be located in a safe and accessible location. The NEC also includes requirements for the wiring methods that are used to connect solar PV systems. The wiring methods must be designed to prevent the ingress of water and other contaminants. When studying the NEC, pay attention to definitions. Understanding the definitions of key terms is essential for interpreting and applying the code correctly. The NEC contains a comprehensive list of definitions in Article 100.1, which you should review carefully. For example, understanding the difference between approved, identified, and labeled is crucial for selecting and installing electrical equipment properly. Familiarize yourself with the NEC chapter layout. The NEC is organized into 9 chapters, each covering a specific area of electrical installations. Chapter 1 covers general requirements, Chapter 2 covers wiring methods, Chapter 3 covers wiring methods, and Chapter 4 covers equipment for general use, and so on. Understanding the layout of the NEC will help you quickly locate the information you need. Practice using the NEC Index. The NEC Index is a valuable tool for finding specific information within the code. Practice using the index to locate the requirements for different types of electrical installations. You can also use the index to find definitions of key terms. Use the NEC tables and examples. The NEC contains numerous tables and examples that illustrate the application of the code requirements. Use these tables and examples to gain a better understanding of how to apply the code in different situations. For example, the tables in Chapter 9 provide information on conductor ampacity, conduit fill, and box fill. Attend NEC training courses. There are many training courses available that can help you learn how to use the NEC. These courses can provide you with a comprehensive overview of the code and help you develop the skills you need to apply it correctly. Consult with experienced electricians. If you have questions about the NEC, don't hesitate to consult with experienced electricians. Experienced electricians can provide you with valuable insights into the application of the code. Stay up to date with NEC changes. The NEC is updated every 3 years. It is important to stay up to date with the latest changes to the code to ensure that your electrical installations are safe and compliant. The NFPA website provides information on the latest NEC changes.